All right, so in problem 11, we have that the U.S. Forest Service is considering adding additional restrictions on the number of vehicles allowed to enter Yellowstone National Park. So to assess public reaction, the service asks a random sample of 150 visitors if they favor the proposal. Of these, 89 say yes. Okay, so we want to construct and interpret a 99% confidence interval for the proportion of all visitors to the Yellowstone public park or national park who favor the restrictions. I kind of said that weird, both. So 99% confidence interval for the proportion of all visitors to Yellowstone who favor the restrictions. And in part B, based on our work in part A, can we say that the U.S. Forest Service concludes that more than half of the visitors to Yellowstone National Park favor the proposal? Justify it. Okay, so let's remember what the 99% confidence interval is, what the form is. We got the, for proportion, that is p hat plus or minus z star times the standard deviation, which will be equal to p hat times 1 minus p hat over the sample size n. Now, this is going to be an example of like a free response problem you may get in the AP exam. So let me go through like the 4-step method so you can answer this problem and get full credit. So we're going to start off with our state. And here we're going to essentially say that we want to estimate P, the true proportion of all visitors to Yellowstone who would favor the restrictions at a 99% confidence level. So let's say we would like to estimate P, which is the true proportion of all visitors who would say they favor the restrictions, who would. At a 99% confidence level. Okay, now, then next we want to state our plan. So what do we plan to do to answer this question? So here we're going to state what inference method we're going to use, and we're going to check if the conditions are met. So for this, we're going to use our one sample z interval for P as long as the conditions are met. We'll use a one sample z interval for P if conditions are met. So the conditions, remember, we want to have the random condition, the 10%, and the large count. So the random condition, let's see, it says that it asks a random sample. So then this is met, we can say that's met. The 10%, we want to make sure that our sample size is no more than 10% of the population size. So we have our sample size is 150. So that means we don't want our population size to, we want our population size to be at least 10 times 150 or at least 1,500. And that's definitely met. We can say that. We can say that there's at least 1,500, visitors to Yellowstone National Park. And then the third condition would then be the large counts condition. Another way to think of this is the number of successes and failures. So it's essentially going to be this, remember it's p hat and n times 1 minus p hat are at least 10. Sorry, n times p hat, n times 1 minus p hat are both at least 10. Now, a simple way to check these is understanding that this is just a number of successes and this is the number of failures, meaning that these are the number of people who voted yes, and these are going to be the number who didn't vote yes. So here it says 89 voted yes, so that's going to end up being 89. And out of the 150, that means 61 didn't vote yes, so the number of failures would be 61. So both of these are at least 10, so that one's met. So far so good. Now the do part is where we do the calculation, which is right here. And this is really just left to your calculator. So P hat will be that 89 out of 150. And we'll see what we get. 89 divided by about 0.593 repeating. Our Z star, we're looking at a 99% confidence interval. So that means there's going to be 1% left over or 0.5% left over on either side of the interval. So we can go to the distribution function in our calculator and go to inverse norm. And we just enter the area to the left or to the, or well, not, well, in this calculator, area to the left side, which is going to be 0.5% or 0.005. I don't have to enter anything else. And again, if you have like a more advanced or newer version of the calculator, it'll be very clear on what, the values mean. But this tells us that our Z star will be about 2.58. And N, our sample size would then be, this is 150. So now we just do the calculation here. So we're going to have about 0.593 repeating plus or minus Z star times this whole thing. So times 2.58 times let's say 0.59 to round it, and that means there would be 0.41 would be 1 minus P hat over 150. Again, this is just the algebra problem. This is just an algebra problem at this point. But here's the worked out if you need it. So 2.58 times, well, let me actually do that piece by piece. 0.59 times 0.41 divided by 150 square rooted times 2.58. So about 0.1036. So I'm going to get 0.563 repeating about plus or minus 0.1036. And then that would lead to an interval of about, let's see. Oh, sorry, 0.593. That's my bad. 0.593. So the upper end about 0.6966. The lower end 0.593 minus 0.1036 of 0.4896. We can round it to about 0.49 if you'd like. So let's go 0.489, 0.4894, my bad, to about 0.6966. So this would be our confidence interval. And then finally, we want to conclude or explain our confidence interval in context. So we would say that we're about 99% confident that this interval captures a true proportion of all visitors who would say that they favor the restrictions. So we are 99% confident that the interval 0.4894 to 0.6966 captures the true proportion of all visitors who would say that they favor the restrictions. Now, again, I really recommend using this format because it's a good way to ensure that you're going to get full credit on AP pre-response problem. And I'm going to put checks like near what they're usually going to be looking for. So in the state part, they're going to be looking for like if it's, you know, that clearly state what parameter you're trying to find. Here it's P, and the confidence level, 99%. For the plan, they want the inference method. And then they also want to make sure you check all the conditions. And then the do part, they want you to show work. And based on this work to get this, and then to have your interval explained in context. Now, the follow-up question based on this, can the U.S. Forest Service conclude that more than half of visitors to Yellowstone National Park favor the proposal? Okay, now this is a good question to make sure you really understand a confidence interval. Now, so more than half would be, anything above 50% or anything above 0.5. Now, when you look at this, you may initially think like, well, most of the values in this interval are above 0.5. So we would say, yeah, it would be reasonable to say that there's more than half of the people that would say yes to this proposal, but it has some values below 0.5, 0.48, 0.49. Those values are below 0.5. And even though it's not centered at those values, or even though it's very much centered, towards the point like 0.59, nearly 60%, we can still reasonably say that 0.489, 0.49, or anything anything right before 0.5 is a plausible value. So then we can't say that we can't say that this would be reasonable to conclude that more than half of the visitors would favor the proposal. And there you go.